So in lecture 2, we're going to learn about various forms of descriptive statistics. And so what we're doing is we sample. We take a subset of the population. The population is everything that we're studying. So if we're studying human behavior, it's not feasible or possible to study every human being. So instead we take a little sample. And what we do is we then look at that sample and make some inferences about the population based on that sample. And one of the things we might be interested in is what's the typical score within that sample, something we call a measure of central tendency, the middle point of that particular group of scores. And one thing that we can calculate is an average or a mean. And so the mean has a particular formula, and we'll see how that's calculated, and has some characteristics. And so I'm going to switch over to the overheads here. And so the mean, here's the formula for the mean. The symbol is this X bar symbol, and that's a statistical symbol. And in psychology, you'll see sometimes a capital M be used for mean because that's easier to type in to a word processor and easier for a publisher to put into a paper. But nevertheless, it means the same thing. And to the right of it is whatever it equals. And this is your sort of first introduction to statistics. And what statistics are is a set of formulas that tell you what to do. It's sort of cookbook math, as I like to say. So it tells you how to calculate the mean. And so it's a set of instructions. The sigma here, capital sigma, Greek letter sigma, means to sum up or add up whatever's to the right of it. In this case, you have X, and X represents all of the individual scores in our group of scores. N refers to the number of scores in that particular group. Now, later on, we're going to use capital N and lowercase n. Capital N generally refers to all of the scores in a particular group, and in this case, if we only have one group of scores, it's unambiguous. In other cases, we'll have three groups of scores. In capital N would refer to all of the scores across all three groups, whereas lowercase n would represent the number of scores in any one particular individual group. So that's just to foreshadow a little bit. But here's like our sample data. Suppose we have that, and as you can see, we have 10 scores there, so that's why the n is 10. And then in the numerator here, I'm just showing you that what you're supposed to do according to this formula is add up all those scores. And so if you added up all these scores divided by 10, your mean would be 4.7. That's how to calculate the mean. A couple of key things here. The mean is sensitive to very extreme scores. So what if we just replaced this 1 with an extreme score like 1,000? And if you do that and you calculate the mean, you'll see it's going to go way up. It's going to be 104.6. Now keep in mind what we're trying to do here, right? This mean of 4.7 seems to fall right in pretty much in the middle of this data set here, right in the middle of that point. And that's in fact really good. It's a measure of central tendency. It's pretty accurate given this group of scores. But if you were to put the 104.6, it would be way out here to the left, and it would be between 1,000 and the next number, 11, but it's not really representative of this particular set of data, right? So that's what we mean by it being sensitive to extreme scores in the distribution. And that's going to be an important property later that we're going to have to sort of contend with or deal with in some of our other formulas. But another property that's important is that the sum of the deviations from the mean equals 0. What this means is if you took the mean, in this case 4.7, and here's our original set of scores, and then you take the difference between each score and the mean. So 11 minus 4.7, well, that's 6.3. 8 minus 4.7, well, that's 3.3, and so on. And then you added all of these up together. So you add 6.3, 3.3, etc. You would find that the sum is 0. That's an important property of the mean. This happens every time. The mean is in the middle of each data point, so that's what it's going to equal. It's going to sum to 0. But that means that we're going to have to take this property into account in some of our other formulas. It will be important to consider. Now, another important measure of central tendency is the median. Now, the median is the point at which 50% of the scores in our group of distributions falls above and 50% of the scores fall below. So calculating it is pretty simple, really. So if you have an odd number of scores, so take this data set, we have an odd number of scores here, right? We have 9 scores. So you find the location of the median. So you just order the data, find the middle point. Well, in this case, you can use this formula to find the location, which number would be the median. So in this case, the fifth number is the median, not the mean. That's a typo. Is the median. So 5 would be the median, okay? If the number of scores is even, it's a little bit trickier, right? So you still order your data, right? So all I did was add a 1 here. You still order the data, and you find the two numbers to average to compute the median. So in this case, we have 10 numbers. So the median is not 5.5. I know you're tempted to say the median is 5.5, but it's not. What this means is you have to average the fifth and the sixth position to get the median, right? So the number in the fifth position, 1, 2, 3, 4, 5, is 3. The number in the sixth position is 5. So the average of those two numbers, the median is somewhere in between these two numbers. The average those two, and you get the median is equal to 4. So that's how you calculate the median. Now our last measure of central tendency is something called the mode. Now the mode is even simpler to calculate. The mode is just the most frequent score in a group of scores. So you just sort of order them and tally them up. So if we had this data set, data are ordered, and we tally them up. So we have 1, 2, 3 3s, right? And we have 2 5s, and then all the other numbers only occur once. So the mode here, the most frequently occurring score, is 3, right? So all three of these are different measures of central tendency. Now, the reason they're different, the reason we use the mean most often, comes back to this last property, and that is the mean is least subject to sampling variation. What that means is if you take sample after sample after sample of the population, and you were to calculate the mean, the median, and the mode, what you would find is the mean would be the most similar from sample to sample, right? The median and the mode would vary more. And what we're going to be doing quite often is taking these samples and making inferences about the population. So for us, that's going to be an important property, and that's why we use the mean most often, is because it's least subject to that sampling variation.